In this lesson, we will start chapter 5 of the course, and I would argue chapter 5 is perhaps the most important chapter in the entire course, because the main focus on chapter 5 is to upgrade your ability, your algebraic skill set. Okay, so let's think about what you're able to do algebraically. Okay, you're able to apply the distributive property, you're able to collect like terms, and you're able to solve some linear equations. And to be honest with you, that's pretty much all you can do. And we really want to continue our discussion about quadratic relations, but unfortunately we can't because your algebraic skill set is very limited. So the whole purpose of this chapter is to upgrade that skill set. So the very first thing we're going to learn how to do is multiply binomials. Okay, so before I multiply binomials, I'm just going to start off with a question that hopefully you looked at in elementary school, which is 41 times 26. Okay, you might not have seen these two-digit numbers, but the idea is that instead of applying your usual algorithm, one way to do this question, well, there's actually a lot of ways to do this question, but I'm going to focus on the way that is related to what I'm trying to teach you, which is multiplying binomials. So the way I'm going to focus is I'm going to take 41 and express it as 40 plus 1. And 26, I'm going to write it as 20 plus 6. Okay, so 41 is 40 plus 1, and 26 is 20 plus 6. Now, why would I write it like this? Because what we're going to do, you can think of this as a rectangle. So 41 is the length and 26 is the width, or vice versa. Okay, so my diagrams are never drawn to scale. That's horrible, but let's just live with that. So this is 41, let's say. Okay, so this would be 40 and this would be 1. And 26, well, like I said, please don't judge the scaling. So this is 26 units, so this would be 20, and this is 6. Now remember, the goal is to find out what 41 times 26 is. So we want to find the area of a rectangle that is 41 units by 26 units. You basically break down this question into 4 parts. If you can find the area of this rectangle, this rectangle, this rectangle, and this rectangle, if you can find the area of the 4 individual rectangles and add them all up, you'll find the area of the big rectangle. Okay, the 41 by 26 rectangle. Okay, so what's the area of this one? 40 by 20. 40 by 20, well, that is 800. How about this one right here? It's 20 by 1, so that's 20. And this one here, 40 by 6 is 240. And lastly here, this is 1 by 6, that's 6. So you can easily find the answer now of this of the area for this 41 by 26 rectangle. You take 800 plus 20 plus 240 plus 6. To be honest with you, I really don't care much about the answer to this question, but you know what? Let's just triple check with our calculator. 800 plus 20 plus 240 plus 6, which is 1066. Okay, now let's triple check. So 41 times 26. Hey, what do you know? So the area of the 4 rectangles make up the area of the big rectangle. Okay, that's what our diagram is showing us. This is very similar to what you did last year, in fact. So I'm just going to highlight what you did last year. Okay, so this is something you did last year. Okay, you took a monomial and multiplied it by a binomial. And this is the diagram you may have seen last year. Okay, you're trying to basically find the area of a rectangle where one of the dimensions is A and the other dimension is B plus C. So this is A, let's say, and this is B and this is C. So what's the area of each the 2 smaller parts, let's say? So this is AB and this is AC. So the area of the big rectangle could be found by taking the sum of the 2 smaller rectangles, AB and AC. So A times all of B plus C is AB plus AC. So this diagram here helps prove to you what you did last year, which was the distributive property. You might have drawn arrows last year, something like that. Okay, so this year, we want, instead of a monomial times a binomial, we are going to do binomial times a binomial. Okay, so I'm going to draw something very similar to my question here at 41 times 26. So A plus B, C plus D. So this is A, B, C, D. So this rectangle here is AC. This rectangle here is BC, AD, BD. And of course, the sum of the big rectangle can be found, the area of the big rectangle could be found by taking the sum of the 4 smaller rectangles. So AC plus BC plus AD plus BD. Okay? So that's how you multiply a binomial with another binomial. And we have an acronym to help us out. Okay, and it's called FOIL. So what you do is you basically spell out FOIL. F represents this first arrow here. To expand, to multiply a binomial by a binomial, you multiply the first term of each binomial together. O stands for outside. You multiply the outside terms. So what's outside? Okay, so A and D will be outside. So that would make our second arrow. And then I stands for inside. Multiply the inside terms. Okay, and then L is last. So this time we multiply the last term of each binomial together. And if you follow the 4 letters, FOIL, you'll complete the process of multiplying a binomial by another binomial. Okay, so if you do that, let me just write it out here. You'll get exactly what I wrote right here. Okay, so A times C is AC, A times D is AD, B times C is BC, and B times D is BD. Okay. I know it doesn't look exactly the same. It's a bit rearranged, but the 4 terms are identical. Okay. All right. Let's do it. So let's look at our first pair of binomials. So x plus 3 and x plus 5. So in the beginning, I'm going to draw the arrows to help show you the process of expanding. All right. So x times x, x squared. X times 5, 5x, 3 times x, 3x, 3 times 5, 15. Okay, let's simplify because I have like terms, 5x and 3x. And I forgot to mention at the beginning of the video, you have to reach a level of mastery with the algebraic skills in this unit because you are going to use the same skill set to succeed in your grade 11 course, in your grade 12 course. So it's critical that not only can you do it, you are able to do it very proficiently. Okay. All right. So let's expand this. I'll draw the arrows again. Okay. First term outside, inside, last. Okay. So 2x times 3x is 6x squared. 2x times 5 will be 10x. Negative 1 times 3. Ooh, be careful. Negative times positive. Negative. Negative 1 times 5, negative 5. Collect your like terms, 6x squared plus 7x minus 5. Okay, 2x minus 3 all squared. So every time we give this question, students always say it's 4x plus 9 because they square the 2x and they square the negative 3. Unfortunately, that is not correct. So I'll prove to you why this is not 4x squared plus 9. So when I see 2x minus 3 all squared, you have to see that whenever you square something, you're basically multiplying the base by itself. So 2x minus 3 times 2x minus 3, hopefully we can all agree that 2x minus 3 times 2x minus 3 is 2x minus 3 all squared. And now when I apply the process of multiplying the 2 binomials, you'll see it's not 4x squared plus 9. Okay, so 2x times 2x over time, I'm going to stop drawing the arrows, okay? 4x squared, and then minus 6x plus 9. So actually, not only do you get the 4x squared and the plus 9, you have this middle term of minus 12x, okay? So please, when you have a binomial squared, you actually get a trinomial. You do not get a binomial. We are going to talk about this a lot more later on in this chapter. But please just understand, squaring a binomial will not give you a binomial. Okay. Another binomial with a binomial. So hopefully by the end of this unit, you'll be able to reach a level of mastery where you can just do this in one step, okay? You expand it and you collect the like terms in your head. So yes, over in the beginning, you're going to show yourself 2 lines, okay? But hopefully by the time it comes to the tests, you'll be able to do this in one step. So I'll show you. So this is going to give me my 15x squared. So 3x and negative 3 is negative 9. And negative 4 times 5 is going to give me negative 20x. So negative 9, negative 20 would give me negative 29x plus 12. Okay? So over time, I really want you to reach a level of mastery. It's really important because, like I said, this is going to help you excel in grade 11 and grade 12. These algebraic skills is really going to put you over the top. All right, let's keep going. Hey, this question looks very familiar. This looks like what you did in grade 9, this L shape. So just like last year, to find the area of this figure, you chopped it up. So let's chop this up. You can chop it up like this, like so, or like so. It doesn't really matter. I will chop it up like this. Okay, so I just need to find the area of this rectangle and find the area of this rectangle and then add it together, and I'll have the area of the L shape. Something else you could do is find the area of the big square and subtract it by the area, or area of this. Imagine it was not an L, it was just a rectangle. Find the area of that big rectangle and subtract it by this area, and you'll get the leftover area, which is the L shape. But I'm just going to do it this way. All right, so back to the 2 rectangles I have here. So I can find the area of this rectangle because I have both dimensions, the length and the width. But for this rectangle, what I'm missing is this dimension here. Okay, I'm going to label this as y. All right. What does y equal? Y is equal to, hopefully you can see, is 7x plus 5 minus 3x plus 4. Okay, sorry, one more time. 7x plus 5 minus, I want to say something, but I'm going to show it to you and then hopefully you can spot the mistake, because very common mistake. So this is what a lot of students write, and unfortunately there's a mistake here. You want to subtract by all of 3x plus 5. Sorry, 3x plus 4. You want to subtract by all of 3x plus 4. But right now, most students write this, which is not subtracting by all of 3x plus 4. You're just subtracting by 3x, and then you're adding by 4. So if you want to subtract by this entire dimension here, what you want to do is put brackets. That totally changes things, okay? Because you get 7x plus 5 minus 3x minus 4, right? So it goes from plus to minus. Anyways, 7x minus 3x, collect your like terms, bam. So the area of the L shape is equal to the area of the sum of the areas of these 2 rectangles. So the first area is 2x plus 3 times 7x plus 5. And then the second one is 5x plus 8 times y. But hey, I know what y is now. Y is 4x plus 1. Okay, so I'm going to collect the term, I'm going to multiply the binomials. I'm going to expand, and I'm going to simplify in one step. Okay, so if you want to take your 2 steps, it's okay. That's fine by me. But I just want to show you how it looks by the end of the unit. So this is going to be 14. This is going to give me 10. 10 plus 21 is 31. 5 through 15. 20x squared. This is going to give me 5 plus 32 is 37, plus 8. Okay. And then collect your like terms. This is going to be 34x squared. This is going to be 68x. This is going to be 23. Therefore, the area is 34x squared plus 68x plus 23 units squared. Okay, so this is basically your grade 9 question you saw like you saw in grade 9, of course. But last year, we always made it such that you didn't have a binomial times a binomial. But now that you have that ability to multiply binomial by binomial, then we can make that happen here. Okay. So example 3 here is another super common mistake that students make. So let's hope that you don't make that same mistake. The expanding here, 4a times all of 3a plus 8. This is last year. This is grade 9, distributive property. Distribute the 4a to 3a and 8. And for this one, same thing. Distribute the 3a to the trinomial. Now this is the grade 10 part. You have to expand here. You have to multiply, you have to square all of 2x minus 5 and then multiply by negative 3. So you know what? Let's go for it. 12a squared. Oops, this is 32a. Ooh, 21a cubed minus 9a squared plus 3a, and then minus 3. Okay, I'm going to write it out like this, just so we don't lose anyone. Okay. All right, let's simplify a little. 21a cubed, there's an a squared term here, a squared term here. So that's 12 minus 9 is 3, so it's 3a squared. 32a plus 3a is 35a. Oops, I forgot that 21a. Let's try again. 32 plus 21, that's going to be 53, plus another 3 would be 56a. Okay. Now, I'm going to multiply the two binomials, and then the resulting trinomial, I'm going to multiply by negative 3. So distribute that negative 3. Okay, so 4x squared minus 20x plus 25. Okay, really try to force yourself to expand and simplify in that one step. It's really worth doing because you're going to be doing this so many times in grade 11 and grade 12. And then, so this is a very classic grade 9 mistake. Students don't distribute the negative 3 fully. They only distribute to the first term, but they forget to distribute the negative 3 to the second and third term. So just watch that mistake. So this can be negative 12. I just noticed something. It's x and a. You know what? It's okay. I think I meant to do AAA or XXX, but it's all good. It's going to work out beautifully because now we need to learn or refresh our memory on writing expressions in standard form. So when you write expressions in standard form, you always go with degree. So the degree can be found by looking or finding the sum of the exponents acting on the variables. So this is a degree 3, degree 2, degree 1, degree 2, degree 1, constant term, so degree 0. Now, if there's a tie in the degree, then you go alpha order. So a squared should come before x squared. So let's write this in standard form for full marks. Bam, there we go. Okay, determine the expression for the volume of the rectangular prism with dimensions 3x minus 1, 5x plus 3, 2x minus 7. Okay, 3x minus 1, 5x plus 3, 2x minus 7. So this to me, you're basically multiplying 3 numbers. Like when I see this, you're really multiplying 3 numbers. So I'm just going to say 4, 3, and 5. When you multiply 4, 3, and 5 together, the order really doesn't matter. Okay, that's the beauty of multiplication. So you could do like 4 times 5 and then times 3. Or you can do 3 times 5 and then times 4. Or so forth and so on. So same could be said here. I'm going to multiply the first two I see. I'm going to multiply 3x minus 1 with 5x plus 3. So let's go back up for a second here. Same could be said here. When we expanded here, you could have really multiplied the negative 3 with 2x minus 5 first, and then multiply by 2x minus 5. But whenever I see a pair of binomials and a constant, I generally, or let's say a monomial and two binomials, I multiply the two binomials first and then multiply by the monomial. Okay, let's see. This would be 15x squared. And this is going to be 9 minus 5 is 4x. So if you can't do this in one step, it's okay. You're going to build that skill set as you practice more and you do the homework questions. I highly recommend. I can't emphasize, like, the amount of time you put into this chapter or this unit is going to really pay dividends. It's going to make you a beast in grade 11 and grade 12, and of course grade 10. All right, so over here, so this one I'll expand because this is a little different. I'll show all my steps because this is a trinomial times a binomial. So take the 15x squared, multiply by 2x minus 2x and the negative 7, so this will be 30x cubed minus 7 times 15, that's 105 x squared. And here 4, multiply, distribute again, that's going to be 8x squared, 4x negative 28x, negative 6x plus 21. And then, of course, collect our like terms. Oops. Oh. That's going to be negative 98. Oops, no, negative 97. Negative 34. Bam. Okay, let me just quickly check something. And then, okay. So I actually want to show one really quick example because it's a common mistake by students, and I just want to make sure we don't make that mistake here. So I'm just write it over here. So let's do 3x minus let's do binomial. So I'll show two quick things. So this is, let's say, 2x minus 1, 3x plus 6. Okay. So 3x. So a lot of students, when they expand, they write this, okay? They write 6, the expansion's perfect. So 12 minus 3 is 9x. So this is what they wrote. Unfortunately, this is incorrect because this subtraction is applied to the product, okay? Basically, we're saying when we subtract, we want to subtract by whatever this is equal to. Well, this we showed, well, I did the math, and this is equal to not just 6x squared, but 6x squared plus 9x minus 6. So if this product is 6x squared plus 9x minus 6, you want to subtract by the entire product, okay? It makes a huge difference. Subtracting by a monomial versus subtracting by a trinomial, yeah, I can't emphasize that enough. But students always forget the brackets. You really have to understand, what are you subtracting by? Are you subtracting by a monomial or a trinomial? Well, I really hope you understand that this product is a trinomial. When you multiply this binomial with this binomial, 2x minus 1 by 3x plus 6, it is not just 6x squared. It is 6x squared plus 9x minus 6. So that's why you need the brackets there. So I'm going to skip a step. I'm going to expand. So multiply by negative 1 and collect my like terms. So 3 minus 9 is negative 6x plus 6. Wow. Okay. And another thing I wanted to show you was multiplying a monomial and a binomial and a binomial. So I don't know. Let's do negative 2. 3x minus 4x plus 7. I don't know. Okay, so here, like I said, when you multiply, when I see this, I really see three numbers. I'm just multiplying 3 numbers together, and the order which you do it doesn't matter, but I would argue the easiest is to multiply the binomial with the binomial and distribute the -2. So you can try it other ways, but hopefully you'll see, well, hopefully you agree that it's the same. So 3x squared, 21 minus 4, 17 minus 28, distribute the -2. That's just grade 9 math. So really try to go over this lesson because we are upgrading our algebraic skill set this whole unit.